Hello everybody, let me share the screen. So today we will be starting the session 3. So in the last session, I spoke about forms of precipitation, types of precipitation. So the precipitation in any form, so it can be rain, drizzle, sleet, glaze, snow, hail, any form, when it reaches the earth's surface, we need to measure it. Now, since the precipitation received in our country, the major part is rainfall. So I'll be talking about measurement of rainfall. So now what is this? Whenever we receive the rainfall or the precipitation in the form of rainfall, we need to measure it and we should be able to know what is the annual rainfall. For this reason, we need to use an instrument which measures it. Now, what is this rainfall? How is it measured? So, rainfall is measured on the basis of vertical depth of water accumulated on a level surface, which means it is going to get collected or accumulated on a level surface during an interval of time. But the condition is this rainfall, whichever gets collected or accumulated, should remain where it falls. It means there should be no losses. It should not have any evaporation loss or transpiration loss or infiltration loss. So whatever falls there, everything should remain there so that we can have a exact estimation of the amount of rainfall received on the earth's surface. So now how do we measure it? We definitely need an instrument to measure it, and the instrument which measure the amount of rainfall which gets accumulated on the ground surface is known as a rain gauge. Now, what is this? It is an open receptacle which is used for collecting rainfall. So, once the rain water gets collected in that open receptacle, which has certain depth, we can measure and we can note it down. Now, these rain gauges are mainly classified into two types. One is non-recording type rain gauge and another one is recording type rain gauge. So the name itself suggests that the first type, that is non-recording type rain gauge, it doesn't record but only collects, and recording type rain gauge collects as well as records it. So let me move to the next slide. So coming to the first type, non-recording type of rain gauges. So the rain gauges which do not record the depth of rainfall but only collect the rainfall is known as a non-recording type of rain gauge. So the commonly used non-recording type of rain gauge in our country is the Simmons rain gauge. Okay, it gives the total rainfall that has occurred at a particular period at a particular place. It consists of a circular collecting area which is 127 mm in diameter. This is connected to a funnel. So the rainwater, as it reaches the ground surface, as it falls from the Earth's atmosphere, it enters this funnel and the funnel discharges the rainfall into a receiving vessel. The funnel and the receiving vessel both are housed in a metallic container. So this rain gauge we can see in the following figure. So this is called a Simmons rain gauge. So it will be placed on a concrete or masonry foundation block, which is 60 by 60 by 60 centimeter. Now this is the ground level, you all can see. So below the ground level, it is 5 centimeter, and above the ground level, 5 centimeter where it will be housed. And totally above, it is 25 centimeter. So totally 30 centimeter. The rim will be above the ground level. Then the diameter is 127 mm or 12.7 centimeter. So you all can see it has a funnel, it has a glass bottle. So the rainwater is going to get collected in this funnel. From the funnel, it will be discharged into the bottle. From this bottle, a man goes and measures it using a measuring jar. So in this way, this funnel and the glass bottle both are housed in a metallic container. So the working is very simple. The rainwater gets collected in this funnel. The funnel discharges into the bottle. The bottle will collect that rainwater. Later on, a man has to go. He has to measure it and record it manually. So in this, no recording happens, only collection happens. So it is called a non-recording rain gauge. But sometimes when the rainfall is very heavy, every day, as per the standards, a man goes at 8:30 a.m. He measures and he records the reading. But in case there is heavy rainfall, intermediate readings, or the man can visit for 2 to 3 times a day and he can take down the recording. So in this way, this is the working of a non-recording rain gauge, that is the Simmons rain gauge. Let me move on to the next part. So this is the explanation. The water collected in the receiving bottle is measured by a graduated measuring jar with an accuracy of 0.1 ml, which means the person who is collecting should be very careful. There should be no errors. Water shouldn't be spilled. Very carefully, he has to pour it into the measuring jar and he has to record it. So this rainfall is measured every day at 8:30 a.m. Indian Standard Time, and this rain gauge gives only depth of rainfall for the previous 24 hours. So during heavy rainfalls, the measurement is done 3 to 4 times a day. So the Simmons rain gauge gives only the depth of rainfall for the previous 24 hours. It doesn't give any recording directly. So it doesn't provide even intensity and rainfall duration of the rainfall during different time intervals of the day. Now, moving on to the second type. So recording type rain gauges. These are the rain gauges which give a permanent automatic rainfall record without any bottle reading. So the arrangement here is such that once the rain gets collected, it records immediately. Simultaneously, the recording also happens. So a pen will be mounted on a clock-driven chart. There is a mechanism where a graph paper is fitted, and as the rain starts getting collected, the pen moves and it also records. So from the chart, the intensity or rate of rainfall in centimeter per hour, that can be for 6 hours, 12 hours, 24 hours, the total amount of rainfall can be obtained. So now various types of recording rain gauges used are tipping bucket rain gauge, weighing bucket rain gauge, siphon or float type rain gauge. But for the syllabus, tipping bucket and weighing bucket rain gauge are not included. So you'll have only siphon type or float type of rain gauge. So let me move on to the float type of rain gauge. Now, I'll talk about the advantages of recording rain gauge and disadvantages of recording rain gauge, and then I'll be explaining about siphon type or flow type of rain gauge. So now, what are the advantages of recording rain gauges? Necessity of an attendant does not arise. So, in case of non-recording, what happens? A attendant, that is manual labor, is required. A person needs to go there. That is, he is the attendant who goes there. The collected water he measures and he records it. But in this case, no, the recording is done automatically. So no attendant is required. The intensity of rainfall at any time as well as total rainfall is obtained. Whereas in the non-recording gauge, it only gives us the total amount of rainfall. Then imagine there is a hilly area which is inaccessible. And if we have kept a non-recording rain gauge there, it will become very difficult for a person to go, reach there and measure it. But in that case, we can go in for a recording rain gauge, which has accessibility easily after a certain period of time. And every day it is inaccessible because it is far off, hilly region. But continuous recording is there. And hence we can obtain it using a recording type of rain gauge. And here, human errors are eliminated because there are attendant who goes, he will pour, he has to measure that rainfall. So obviously he has to place that water from the bottle into a measuring jar. So there certain human errors can occur. One spilling can happen. We can have a less estimate of that rainfall, or another reason, it can be his eyesight. He may read it wrong and note it down wrongly. So that can happen. So all these are eliminated in recording type of rain gauges. Then, given the capacity of the gauges is large, that is in case of recording rain gauge, so no need to worry. Then the time interval also is recorded here. At what time, the storm duration, the intensity, everything can be determined. But the disadvantages of recording rain gauge are High initial investment is required, so it is very costly. Then recording is not reliable when there is some fault in that gauge due to some mechanical error or electrical error can happen, and faults cannot be, we cannot stop it, and hence faults are there. So moving on to the Siemens type of rain gauge. So how it works, this is a recording type of rain gauge. So it has a receiver and funnel arrangement. The rainfall is collected in that funnel, and again in the receiving channel it uh, will discharge it, and there is a float mechanism, what we say a float chamber. So as the water accumulated, the float rises. Then as the float rises, it is attached to a pen, okay, which will continuously move and mark. So that pen arm is attached to the float mechanism, and that continuously records the rainfall on a clock driven chart and also produces a mass curve of the rainfall. So when this water level rises above the crest of the siphon, the accumulated water in the container will be drained off by siphonic action. The rain gauge is ready to receive the new rainfall. So let me show you all this diagram. So this is a siphon type or a float type of rain gauge or recording rain gauge. It's also called an integrated rain gauge, as it depicts an integrated graph of rainfall with respect to time. So you all can see the arrangement, what is done here. So this is the funnel. The rainwater gets collected in this funnel. The funnel discharges into this chamber, collecting chamber. Okay, this collecting chamber has a float here. It also has a siphon here. So as the water enters this float chamber, this is called a float chamber, this is called a siphonic chamber. So this collecting area, as the water enters the float chamber, this float starts rising. As it starts rising, it is attached to a pen, and this is the mechanism or revolving drum, what we say. A chart is mounted there, a pen is there. So it's a clock mechanism. As this water gets discharged into the float chamber, this starts rising up, the pen starts moving, and it starts recording. So once this float chamber is totally full, the water enters the siphonic chamber, and siphonic action happens and the water is drained out. So this is a continuous process which happens, and we will have a continuous recording of the amount of rainfall received. In case there is snowfall, also we can measure by removing the funnel where the snow directly gets collected in the receiving chamber, and we can measure it. So in this way, the siphon type or float type of recording rain gauge works. Now, moving on to the factors governing selection of site for rain gauge station. The site for rain gauge station should be an open space without the presence of trees or any covering. So it should be an open land, plain land without any vegetation there. Then it should be properly secured by fencing so that it is not disturbed by animals or people shouldn't enter there. Then the site for rain gauge station should be a true representation of the area which is supposed to give rainfall data. So there should be no losses, no rainfall losses should happen such that evaporation, transpiration, infiltration doesn't take place there, and all the water collected should be a true representative of the actual rainfall receiving on the earth's surface. The distance of any object or fence from the rain gauge should not be less than twice the height of the object. So any objects with a certain height should not be there. Okay, then the fence also should in no case less than 30 meter should be available there. Then the rain gauge should be set up on the peak or sides of a hill, but of a nearby fairly level ground. The ground should be level. The rain gauge should be protected from high winds because it shouldn't be disturbed. The rain gauge should be easily accessible to the observers at all times so that they can reach there and record the amount of rainfall. Now, let me move on to the next topic, that is determination of average precipitation over an area. So, now once rainfall is collected at different rain gauge stations, we need to determine what is the average precipitation over a certain area. So the rainfall measured by a rain gauge is called point precipitation or point rainfall. at a single point when it is collected. But this rainfall at a single point when it is less than 50 kilometer square, the area, if it is less, then a single rain gauge station will give us directly the rainfall amount in that area. But if there is a large area, so this rain point precipitation or point rainfall at a particular area with a single rain gauge station, it represents the rainfall pattern over small area surrounding that rain gauge station. But however, in nature, rainfall pattern varies widely. So if the area is large enough, we will go in for installation of many rain gauge stations. That time, we need to find out what is the average precipitation in that area. So the average precipitation over an area can be obtained only if several rain gauges are evenly distributed over that area. But there is always limitation to establish several rain gauges. So at minimal point or minimum number of rain gauges have to be adopted, installed, and we have to find out the average precipitation. This drawback can be overcoming by adopting certain methods as mentioned below, which gives us the fair results. So the first method which is used is the arithmetic mean method. Okay, so what is this method? In this method, to determine the average precipitation over an area, the rainfall data of all the available stations are added and divided by the number of stations to give an arithmetic mean for the area. So it's a simple method to estimate the average precipitation. So imagine there is a certain area. We have installed 1, 3, 6, any number of rain gauge stations. So each rain gauge station has recorded certain amount of precipitation. For example, what is given here? If P1, P2, and P3 are the precipitations recorded at 3 stations A, B, and C, respectively, then average precipitation of the area covered by the rain gauges is given by P average is equal to P1 plus P2 plus P3 by 3. This is the most simple method. How many number of stations you have? If it is 6, you're going to collect all these 6 datas, P1, P2, P3, P4, P5, P6, divide by 6, and you will get the mean precipitation. So arithmetic mean method is one of the simplest method which is used to determine the average precipitation. And it is a simple calculation where all the precipitations at different rain gauge stations are added and it is divided by the number of rain gauge stations. This method can be used if the area is reasonably flat and individual gauge readings do not deviate from the mean, that is average. So there is no much fluctuation over the entire area. There is a uniform rainfall over the entire area and the area is plain, it is flat. Then we go in for this arithmetic mean method. This method does not consider areal variation of rainfall, non-even distribution of gauges, orographic influences, that is because of uh, inundations or hilly areas which are present on the area obstructions, then this method cannot be used. This method can also be used to determine the missing rainfall reading from any station in the given area. The second method is Thiessen polygon method. So what is this? This is also known as weighted mean method. So the weightage factor is taken here. This method is very accurate for catchments having areas from 500 to 5,000 kilometers square. In this method, rainfall recorded at each station is given a weightage factor on the basis of the area enclosing that area. So what is the procedure? Let me tell you all. The rain gauge station positions are marked on the catchment plan. So the catchment area is taken. All the rain gauge stations will be marked. Each of these stations positions are joined by straight lines. Then perpendicular bisectors will be drawn to these previous lines and they will be extended up to the boundary of the catchment and they are going to form a polygon around each station. So that area of each polygon will be noted. The area will be measured using a planimeter. Then the average precipitation is calculated. So let me show you all how it is done. So just see this figure. This is the catchment area, what you all can see. So here 1, 2, 3, 4, 5, and 6 are the rain gauge stations. So in each rain gauge station, the rain gauges are placed. Now all these rain gauge stations are joined by straight lines. So 1 to 2, 2 to 3, 1 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 1, 1 to 3. In this way, all straight lines are drawn connecting the rain gauge stations. After that, you can see here the perpendicular bisectors. So between 1 and 2, between 1 and 6, when we draw a perpendicular bisector, it is going to divide here at D, at K, at B. Later on, that has to join the boundary of the catchment, which is extended till J. Similarly, this triangle, when it is taken, again you draw the perpendicular bisectors between 2 and 3, between 1 and 2. So the same line extends here and it joins at D. This is end boundary Z and this is C. So now you can see around the station A, the perpendicular bisectors are drawn. After that, we have arrived at a polygon. So at each rain gauge station, which is joined by straight line, it has to be divided by the perpendicular bisectors, which gives a polygon along that area around that rain gauge station, and that has to be measured by a planimeter. So now you all can see here, surrounding the rain gauge station, you all can see the area A, B, C, and D. So this is area A1. Next, if we move on to station 2, it is KADC. So see here, K, A, D, and C. Rain gauge station 3, you can see CDCGF, CDEGF. Around rain gauge station 4, it is FGH, that's all. Then 5, you can see here, JBCGH. Okay, or even you can say BJCGH. Around 6, it is just JBAK. JBAK, BG. You can say anything. Okay. In this way, this is the bounded area around each rain gauge station. After the rain gauge stations are joined by straight lines and they are divided by perpendicular bisectors, we will come out with polygons around each rain gauge station, and that area of the polygon is measured. And there we give the weightage factor. So total area will be known, and each rain gauge station is surrounded by a certain area A1, and weightage factor is given where it is told as A1 by A, A2 by A. So this is 2. So around the rain gauge station 2, it is A2, around 3, A3, A4, A5, A6. So A1 by A is the weightage factor around rain gauge station 1. Similarly, 2, 3, 4, 5, A2 by A, A3 by A, A4 by A, A5 by A, and A6 by A. Now, the average precipitation is calculated over an area by the formula P average is equal to P1A1 plus P2A2 plus P3A3 up to PNAN divided by summation A, or A1 plus A2 plus A3 up to AN. So we know P1, P2, P3 are the rain precipitations at different rain gauge stations, or rainfall amounts obtained from the N rain gauge stations respectively. And A1, A2, A3 are the areas of the polygons. Up till AN are the areas of the polygons surrounding the each station. So in this way, we can draw the polygons, find the area, and determine the average precipitation. Moving on to the next method, it is isoheightal method. So what are isoheights? As we know, in surveying, you will have read about contours. So these isoheights are something very similar to contours. So they are the imaginary lines which join points of equal precipitation or points of equal rainfall in a given area, similar to contours in a given area. So you all can say here where the rainfall will be determined with the same point, and with straight lines it is going to be joined, and that is known as isoheight. An isoheightal method for determining the average precipitation of an area, isoheights of different values are sketched in a manner similar to the contours in surveying in given area. The mean of two adjacent isoheightal values is assumed to be the precipitation of the area lying between two isoheights. So in isoheightal, we will sketch that. It is similar to contours. They are the area lying between two isoheights. So to get the average precipitation of an area, procedure to be followed is each area between the isoheights is multiplied with the corresponding mean isoheightal value. So if it is given 15 to 20 is your isoheightal area, then we say 15 plus 20 divided by 2 will give that mean. So that becomes our isoheightal area. All such products are summed up, and the sum obtained from above is divided by total area of the catchment, and the quotient obtained from above represents the average precipitation over the gauging area. So in this way, we determine the average precipitation by average precipitation. Okay, that is, we take the mean. Because various rain gauge stations are installed, they don't have uniform distribution of rainfall. They may vary. If it is uniform on a flat land, then we go in for arithmetic mean method. If it is not, we can clearly use isohydral method and polygon method. In Thiessen polygon method, the polygon area is determined using a planimeter. Then the area is determined, then weightage factor is given A1 by A, then we multiply it with A1 P1. And in this way, the precipitations will be known and the average precipitation is determined. In ISO heights, we join the rainfall of equal magnitude, and then after drawing them, the mean is taken. Okay, then we multiply it and we get the average precipitation. That's all for this session. Thank you.